All right, guys, I'm going to go through the questions on page 7 and 8 with you and just flip back and forth between the article and the journal page and just show you where you can find some of these answers. So, in case you need to go back. So, I'll start at the very top of the article. So, one says, why are the poles of a magnet called north and south? A little hint, it has something to do with the earth. So, see this section, magnetic poles, right here. This paragraph is where you'll find that answer. So what you can do is you can always pause this video right now and read through that paragraph and then go to your journal and answer that question. So this is where, in this area, is where you'd find the answer for number 1. Number 2 says, explain the cause and effect relationship between orientation of magnets, which is the direction of the poles, and the magnetic force. So orientation, let's see. Okay, so this section right here, magnetic force, is where you'll find the answer for number 2. And you can also use the orientation diagram down here to help you. Okay. Let's see. Okay, number 3, draw a force diagram to show or to model how the orientation affects the strength and or direction of the magnetic force. So you're basically just drawing a force diagram like these. These are force diagrams to show the magnetic force, but you want to focus on orientation. So you're going to draw a force diagram of your own, still something similar to this, to show how orientation affects the strength. So whichever way the north and the south poles are facing, you want to show how that affects the magnetic force. For example, if the north poles are both facing each other, is it going to have a strong magnetic force? Or would it have a stronger magnetic force if it's north and south pole facing each other? Okay, number 3. Explain the cause and effect relationship between the distance of interacting objects and the strength of magnetic force. You can support your answer with evidence from the distance lab. So you could also look at your distance diagram here to help you. How does distance affect the magnetic strength or force? And number 4, what is the difference between a domain before and after it has been magnetized? How did this help you magnetize materials? So we're going to look at the magnetic fields. Actually, scroll down a little bit. What makes a material magnetic? This is where you'll want to reread this section for that answer if you need to. It talks about the different domains, which would be here and here. So again, what is the difference between a domain before, be here, and after, here, it's magnetized? And how can that help you magnetize different materials? So for example, like the paper clips and the nail that we talked about in the article. And then we didn't get to look at it at figure 1.6, so we are going to skip number 5. So you do not need to do number 5. All right, feel free to go back and look at any of these videos, guys, to help you answer questions 1 through 4 in your journal page. Well, actually, there's 2 number 3s, so I guess technically that's 5 questions. All right, thank you, guys.